Hello everyone, I am Aishwarya, Assistant Professor, Department of Mathematics, Dr. SNS Radhalakshmi College of Arts and Science. Today we are going to see a topic correlation. The word correlation is used in everyday life to denote some form of association. We might say that we have noticed a correlation between foggy days and attacks of busyness. However, in statistical terms, we use correlation to denote association between two quantitative variables. We also assume that the association is linear, that one variable increases or decreases a fixed amount for a unit increase or decrease in the other. The other technique that is often used in these circumstances is regression, which involves estimating the best straight line to summarize the association. Correlation coefficient. The degree of association is measured by a correlation coefficient that is denoted by small r. It is sometimes called Pearson's correlation coefficient after its originator and is a measure of linear association. If a curved line is needed to express the relationship, other and more complicated measures of correlation must be used. The correlation coefficient is measured on a scale that varies from +1 to 0 to -1. Complete correlation between two variables is expressed by either +1 or -1. When one variable increases as the other increases, the correlation is positive. When one decreases and other increases, it is negative. So next we are going to see types of correlation. The scatter plot explains the correlation between two attributes or variables. It represents how closely the two variables are connected. There can be three such situations to see the relation between two variables. So the first one is positive correlation, when the values of two variables move in the same direction so that an increase or decrease in the value of one variable is followed by an increase or decrease of the value of the other variable, then it will be called as a positive correlation. And this will be the diagram for the strong positive correlation. So the next one is negative correlation, when the values of the two variables moves in the opposite direction so that an increase or decrease in the value of one variable is followed by the decrease or increase in the value of the other variable is called as a negative variable, and this will be the diagram for the strong negative correlation. So the next one is no correlation. When there is no linear dependence or no relation between two variables, then it will be called as a no correlation. And this will be the diagrammatic representation of correlation, no correlation. So the next will be the formula for the correlation coefficient, that is R is equal to n into summation xy minus summation x into summation y divided by square root of n into summation x square minus summation x the whole square into n into summation y square minus summation y the whole square. So next we are going to see a problem related to the correlation coefficient. Calculate the correlation coefficient between x and y and comment their relationship. So here the data is given for x and y. So we have to find the correlation between these two variables. So first we have to apply the formula, that is the called Pearson's correlation coefficient, that is R is equal to n into summation xy minus summation x into summation y divided by square root of summation square root of n into summation x square minus summation x the whole square into square root of n into summation y square minus summation y the whole square. So we have to find the values given in the formulas. So the given term x and y are given. So after that we have to find the value of so we have to find the value of xy. So for to find xy, we have to multiply the term x into y, that is 2 into 4, 8. So the remaining terms also we have to multiply. So the next column is we have to calculate the x square. For x square, we have to square the values of x. That is we have to square the 2. So 2 square will be 4, 6 square will be 36. So for the remaining terms also we have to square and put the values in the column of x square. So on the last we have to find the value of y square. For y square we have to square the value of y. So after that we have to find the summation for all these values. So summation means we have to add the value. For summation x we have to add all the x values and put the values in the summation x. So the summation x value will be 56 and the summation y value will be 112 and summation xy will be 1312. Summation x square will be 6566 and summation y square will be 2624. So, so we find all the values of summation. So after that we have to substitute it in the formula. So by substituting the formula, here we have to find the n value also. So n value means we have to find how many data are given. Here when we count, we get the 6 data are given. So the n value will be 6. So then we have to substitute all the values, all the we have to substitute all the founded values in the formula. So after the calculation, I obtained an answer as 1.0001. So which represent the perfect positive correlation. Thank you.